Welcome to the deep dive.
Yeah,
We have what's a massive stack of source material today,
it really is.
and it connects some of the largest infrastructure shifts happening on a global scale, all driven by the AI boom with these just startling breakthroughs.
Right. In the microscopic world, we're talking fusion energy, molecular biology.
And even, of all things, canine cognition.
It's a fascinating cross-section. We're essentially tracking two parallel stories here. On one hand, you have the tremendous physical demands AI is placing on our planet's energy systems.
And on the other,
And on the other, you have this relentless progress in foundational science that might fundamentally change human life, food production.
things completely independent of the current tech cycle.
Exactly.
That's a perfect way to frame it.
Yeah.
So our mission today is to distill those core insights, right? We want to understand how AI is fundamentally reshaping global energy infrastructure and also uncover those surprising kind of aha scientific advancements.
The ones with massive long-term impact on our health and our environment.
Okay, let's unpack this.
I think we have to begin with the most dramatic physical manifestation of the AI boom, and that is power demand.
Oh, absolutely.
The growth of data centers is forcing infrastructure decisions we haven't seen in decades.
Right. I mean, we've become so focused on the algorithms, the software, the models, that we sometimes forget they're literally housed in these giant warehouses.
Warehouses that need continuous high-density power.
And the biggest story detailing how we're solving that energy crisis is, well, it's a strategic pivot toward an energy source many people thought was basically retired.
Nuclear power.
Nuclear power.
We are witnessing a clear nuclear power renaissance, and not just as, say, a climate solution. It's a critical tool for national technology competitiveness.
And the prime example of this strategic pivot right now is the 3 Mile Island nuclear reactor in Pennsylvania.
That detail is just incredible considering the history.
Right. I mean, that reactor has been shut down. It's been in the process of decommissioning since 2019.
And now, suddenly, it's not just restarting.
It's doing so with massive institutional backing.
It's a profound reversal, and the specifics really tell the whole story. The restart is being lubricated by a $1 billion federal energy loan.
$1 billion.
But the operational backbone, the real core of it, is a strategic power purchasing agreement.
A deal between Constellation Energy, which owns the facility,
And Microsoft.
So wait, this isn't just some generic subsidy. This is the federal government backing a private deal explicitly to generate reliable, round-the-clock electricity for Microsoft's AI data centers.
That's it. That connection is the key insight here.
Wow.
Absolutely. When AI data centers need power, they need reliability above all else. They just are not compatible with intermittent power sources.
Because you can't have a power fluctuation in the middle of a massive model training run.
Exactly. You can't tolerate unexpected shutdowns. And nuclear power, with its high capacity factor, provides that unwavering baseline stability.
But hold on, historically, nuclear has faced immense resistance. I mean, not just regulatory hurdles, but huge public cost concerns and these decades-long construction timelines. So does this sudden restart, backed by a huge tech company, does it actually address those structural historical problems? Or is this just a partnership of desperation for power?
That's a crucial question. This specific situation, it benefits from TMI being a pre-existing facility.
So no new construction delays.
Right. That issue is mitigated. The partnership structure is the truly innovative part. By having a major, stable buyer like Microsoft committed for the long haul.
It underwrites the financial risk for Constellation.
Exactly. It bypasses a lot of the traditional capital sourcing challenges that plague new nuclear projects. It basically signals to the market that AI is a powerful, reliable demand source.
So AI doesn't just need energy. It is structurally changing the financial viability of these huge energy projects.
It's absorbing the risks associated with the high cost of reliable baseline power.
And the implications of that are enormous.
They are. This reduces American reliance on volatile foreign power sources, enhances energy security, and it ensures that the growth of domestic AI won't be bottlenecked by supply. It's a necessary, if dramatic, shift.
Restarting old infrastructure to support the computing demands of the future.
But this massive build-out of physical power, it isn't worth anything if the outputs lack integrity.
Right.
Which brings us to the challenge of trust and accuracy. As AI gets embedded in our lives, its failures, especially in sensitive areas, become unavoidable headlines.
And that leads us directly to Google's recent actions, specifically around their health information summaries. We've seen them start removing their AI overviews feature for certain critical medical queries.
Correct. And this is a subtle but, well, it's a potent admission by a tech giant. The AI overviews were intended to be helpful.
Those quick one-paragraph summaries you see at the top of a search result.
Yeah, they simplify complex topics, they aim for instant utility.
But the investigation showed that when you apply that simplification to sensitive health topics, it doesn't just become less useful, it can become actively misleading, potentially harmful.
The nuance just gets lost, and the risk goes way up.
Precisely. Health inquiries are rarely general. They need personalized context, high degrees of accuracy, specific sources.
And the AI summaries, just by their nature, they flatten all that complexity. So when the investigation found the feature was generating misleading or, contextually inaccurate information,
For conditions that require very careful consideration.
they realized the potential for eroding user trust was just too high.
It raises a fundamental tension for deploying AI, doesn't it? The push for instant, simple answers versus the absolute necessity of transparency and reliability in life-critical fields like health.
A quick answer is not a good answer if it's wrong.
Right.
And that tension is where the industry is really struggling. How do they maximize the utility of their models without sacrificing credibility?
And this decision to pull back shows that where physical or financial harm is possible, convenience has to take a backseat.
It has to. And for you, the listener, this really highlights the need to apply a critical lens to any quick AI summary, especially when you're dealing with personal health. This raises an important question. Is there a fundamental limit to how much we should let AI summarize information that really requires a doctor's context?
That's the question facing us all. Okay, so pivoting now. From the infrastructure supporting AI and the accuracy challenges within it, let's explore pure breakthrough science.
The aha moments.
Exactly. The moments that promise to reshape our physical world, whether that's massive energy production or microscopic molecular control. And we'll start with energy, but the experimental kind.
Fusion.
Fusion.
This takes us into the world of plasma physics, specifically to China's fully superconducting East Tokamak, their artificial sun.
Okay.
They have achieved a significant experimental confirmation of a theoretical density-free regime.
That sounds incredibly technical. Can you break down what that phrase, density-free regime, what that actually means, and why it's such a huge hurdle for fusion?
Absolutely. So think of the fusion plasma. It's hotter than the sun, and it's confined by these powerful magnetic fields inside that donut-shaped tokamak. For decades, one of the biggest problems was plasma turbulence. As you increase the density of the plasma, so you're cramming more fuel into the reaction chamber to get more power.
The plasma would become unstable.
Inevitably. It creates these bursts of turbulence that would cool the plasma down, disrupt the magnetic containment. This density limit, it's known as the Greenwald limit.
And that was considered a hard ceiling on reactor performance.
For decades, yes. We always assumed you just couldn't push the fuel density past a certain point without the whole reaction just breaking down.
So what did the East team confirm?
They confirmed a scenario where the plasma can stay stable even when it's pushed beyond those traditional density limits. By entering this density-free regime, they are essentially proving that the ceiling might be much, much higher than we calculated.
Or maybe, in some contexts, it just doesn't exist.
Perhaps.
Wow. So if that holds up and can be scaled, it doesn't just mean a small improvement. It fundamentally changes the design parameters for commercial fusion reactors.
It removes a major engineering obstacle that we thought was basically immutable.
That is enormous.
It pushes us closer to a practical, net energy producing fusion environment. And the breakthroughs, they just continue at the molecular scale.
Okay, so let's move from energy production to human optimization. Specifically, how we treat the human brain during its most restorative phase.
Sleep.
Sleep. We know that decades of common prescription sleep aids, they often have this major side effect. They suppress REM sleep.
The rapid eye movement phase, it's crucial for memory consolidation, emotional processing.
Which is why chronic use of some sleeping pills can leave people feeling, groggy or mentally foggy.
This is why an experimental drug called BMB-101 is so interesting. It's developed by Bright Minds Biosciences, and it appears to reverse this paradigm completely.
What were the specific results in the clinical trials? They were pretty striking.
They were. The drug was tested on epilepsy patients, and they saw REM sleep boosted by an average of 90%.
90%.
And crucially, this enhancement didn't make the patient sleep longer overall. It didn't just sedate them.
It enhanced the quality of the sleep.
The quality and the intensity of that restorative period. It concentrated the benefits of REM sleep into the existing sleep cycle.
That distinction is so critical. We're talking about enhancing the brain's core restorative process, not just adding more time in bed.
And the implications are profound. If we can pharmaceutically restore or enhance this REM phase, it opens up new avenues for treating widespread cognitive issues.
Potentially mitigating symptoms associated with cognitive decline, Parkinson's, Alzheimer's.
It's a targeted chemical solution to a decades-old neurological problem.
And while we are on breakthrough control over biological processes, let's shift to agriculture. There's news from University of Illinois researchers who've unveiled a system they call Stomata Insight.
This is a total game changer for plant science. For the first time, researchers can literally watch plants breathe in real time.
With microscopic precision.
Yes?
And we're talking about the stomata here, right?
Yeah.
The microscopic pores on leaves that handle gas exchange.
That's right. Previously, observing stomata activity, it often relied on static snapshots or just indirect measurements of gas exchange. You couldn't capture the rapid, dynamic responses plants have to stress.
So what does Stomata Insight do differently?
It combines high-resolution imaging with simultaneous precise measurement of carbon dioxide and water vapor flowing through those pores in real time.
And why does seeing those real-time dynamics matter so much for agriculture?
It allows scientists to finally answer a crucial question. How and when exactly does a plant decide to conserve water?
So if you can see the stomata closing minute by minute under simulated drought conditions.
You can identify the genetic traits that make some plants highly water efficient. This tool is absolutely essential for breeding the next generation of drought-resistant crops.
Which is critical for securing the global food supply against climate change.
It really is.
That is just incredible control and insight. Okay, now for a complete shift, let's move to a different type of cognition, one that might change how you view your furry companion when you're talking on the phone.
Ah, yes. Moving from advanced particle physics to our border collies. A welcome change of pace.
I think so.
Yeah.
So scientists did this study focusing on certain rare, gifted word learner dogs.
These are the dogs, mostly border collies, who can learn dozens, sometimes hundreds, of object names.
Right. And the question was, are they actively learning the way we teach them, or are they eavesdropping?
And the findings were, well, quite conversational. They set up these scenarios where owners would casually mention the name of a brand new unseen toy during a conversation with a researcher.
But they never directly addressed the dog or asked it to do anything?
Never. And what happened?
What happened?
They found that these gifted dogs could retrieve the new toy 80% of the time.
Just from overhearing its name?
Simply after overhearing its name and passing conversation, they were absorbing new vocabulary passively just from environmental exposure, not focused training.
That ability, I mean, the capacity to learn language just by overhearing it, that's the same cognitive process you see in 18-month-old human children.
It is. It suggests that while you're talking on the phone, your dog might not just be waiting for a walk, it might be building a vocabulary.
It definitely adds a new layer to the relationship. You might want to start considering your dog a third person in the room.
I think you might be right.
So, okay, we've covered massive energy shifts, profound scientific breakthroughs. So what does this all mean for you right now, today, in your daily work or your creative projects?
Let's transition to a roundup of some trending AI tools.
And focus on the powerful trends they represent.
Well, the central trend right now is the convergence of specialized tasks into these unified automated workflows. AI tools are no longer just doing one thing well.
They're managing entire processes.
Exactly.
Okay, let's start with data visualization and presentation. This is key for anyone needing to communicate insights clearly. We have Gridfy.
Gridfy tackles that tedious task of transforming raw, static data like the spreadsheets you probably already have into professional, live, interactive widgets.
You can just embed right into a website or a presentation.
Seamlessly. It automates that whole data-to-display pipeline.
Okay, next, for tackling the complexity of multi-step processes, we're looking at Instruct.
Instruct represents the move towards semantic automation. So instead of spending hours building complex multi-app connections with nodes and logic gates,
You just describe the task you want done.
you connect your apps, your email, your CRM, project management software, and then describe the required complex task in plain, natural language. It handles all the intricate cross-app communication for you.
For those involved in visual creation, we're seeing platforms that centralize the best of a fragmented model ecosystem. Let's look at Masonry.
Masonry is responding to the fact that no single AI model is best at everything. It gives you a centralized platform for creating, remixing, and refining visuals by offering access to a bunch of major AI models,
All in one workspace.
all in one visual workspace. It eliminates all that model hopping.
And finally, we have specialization refining video generation, specifically with Kling 2.6.
So while a lot of tools can create amazing static images or fluid video, Kling 2.6 is solving the challenge of control.
Okay.
Its new motion control feature allows users to impose very precise constraints on character animation. So you get this highly granular control over movement, pose, trajectory.
So moving from general output to professional specific direction.
That's it. And as a sort of all-in-one workspace for the generalist, Anygen stands out.
Right.
Anygen is an integrated, collaborative AI workspace. So if you need to go from data analysis to content creation, then to presentation development, you can do it all within their shared environment
It's designed to minimize context switching.
and maximize collaborative efficiency.
That gives you a powerful set of tools that really show how AI is moving beyond simple generation and into managing complex real-world workflows.
We've covered a remarkable range today.
We really have.
We started with the necessity of building this massive, reliable physical energy infrastructure, the nuclear renaissance, funded by tech demands.
And we balance that by exploring the critical need for integrity and accuracy in AI outputs, highlighted by that Google Health Query pullback.
And finally, we saw the shifting boundaries of science and cognition, from pushing fusion limits to finding new ways to restore human and agricultural life.
It paints this picture where the demands of our computing infrastructure are just racing ahead, pushing both financial models and scientific breakthroughs at an astonishing speed.
And that leads to a final thought for you to explore. Given that AI is demanding massive external power sources like nuclear reactors to operate,
While at the same time we're developing drugs to enhance the complex restorative power of the human brain through REM sleep.
consider this. Where will the critical bottlenecks emerge first? In the massive physical infrastructure needed to power AI, or in the human capacity to fully utilize, control, and understand this rapidly accelerating technology?
A question that deserves a lot of processing time, perhaps during a high-quality, REM-enhanced sleep. Thank you for joining us for this deep dive.
We hope these insights serve you well.